So if I'm solving this without graphing, if I look at the first case, then I need to determine, well, is it one, no, or infinitely many solutions? So the first thing I'm going to do is I'm going to put both equations in the same form. This is already in slope-intercept, so I'm going to put the other one in slope-intercept. And I'm going to say that if this has 5y is equal to negative 3x plus 15, then y would equal negative 3 over 5x plus 3. Right now we can see that they have the same slope, but this one has a y-intercept of 0 and this one has a y-intercept of 3. They're going to be parallel. No solution. In the second case, negative 4y is going to equal negative x minus 8, or y is going to equal 1 over 4x. And then when I divide the negative 8 by negative 4, I get plus 2. And then I can see that in this case, I have the same slope, same y-intercept. There's going to be infinitely many solutions. For the last example, I'm going to say that y is equal to negative 7x plus 12. And for the second equation, I can say negative 6y is equal to negative x plus 5, or y is equal to 1 over 6x minus 5 over 6. And as soon as I see that they have different slopes, I can state that it has one solution. The x-intercepts don't make a difference at that point. It's just based on if it has a different slope, one solution, and we're done. All right, if I'm solving a system graphically by changing the calculator window, so often the solution to a system will not be visible in the basic settings, and so then I'll need to change the window settings in order to be able to zoom out and see where these points are actually going to cross. So for this example, it says, at a local high school, the Students' Council decided to sell sweaters to students. The cost of designing the sweaters included a fixed cost of $600 plus $5 per sweater. The Students' Council planned to sell the sweaters for $25 each. The cost and revenue can be represented by the following system of equations where D represents the dollar cost and N represents the number of sweaters sold. So for one equation, I wind up with D is equal to 600 plus 5N. I got that from here. And in the second part, D is equal to 25N, which we got from the second part here. Using a graphing calculator to graph each equation and sketch each graph on the grid provided. So the biggest thing is I'm going to have to change my window settings, and you can see here that we have a y max of 1,000. We have a y min of negative 100, and that each line is going to be worth 50. So I could say that this is going to be negative 100, positive 1,000, and 50. We can also see that they changed our n values, so it looks like it goes back to about negative 10. It's going to a maximum of what looks like 50 or 55. And then each one of these little ticks is going to be worth 2. And then they went ahead and we're going to graph out this information. So we're going to sketch it on the grid. We can use our table of values or any other information that we can find here. And then we will see that if we're doing this properly, we're going to wind up with our two equations. One equation should look something like this. And our other equation is going to start at that 600. And it is going to look something like this. And if I did it a little bit more clearly, I'm going to see that I have an intersecting point that exists in here. So, for part B, how much profit or loss will be made if 20 sweaters are sold? Well, I can say that the cost is going to equal 600 plus 5 times 20, which is going to be $700. I can say that the revenue, the amount of money I'm bringing in, is going to equal 25 times 20, or $500. Which means that the profit is always going to equal the cost minus the revenue I'm going to come in at a loss of $200 if I only sell 20 of these sweaters. If I sell 50 sweaters, well, the cost is going to equal 600 plus 5 times 50, or $850. The revenue, the amount of money I'm bringing in, is going to be 25 times 50, which is the same as $1,250. The profit is going to equal the revenue minus the cost, which is going to be $400. So I'm going to make $400 in this case. Sorry, in the last one I just put them in backwards. Let's fix that real quick. It's going to be the 500 minus the 700, or the revenue minus the cost. The break-even point is when I am making no money, but no profit is made. Where's the break-even point? Well, the break-even point is going to be where the two lines cross. If I am going to figure out what the break-even point is on here, well, it looks like the break-even point is about 30. I can put it into my calculator, and then I'm going to see that the X value when it breaks even is going to be 30 sweaters. If all 850 students purchase a sweater, how much profit would be made? Well, I can do that using the same method that we did in the previous cases. I can say the cost is going to equal the 600 plus 5 times 850, which in this case is going to be $4,850. The revenue is going to equal 25 times 850. The amount of money I'm bringing in is going to be $21,250. The profit is going to be the amount of money I brought in, $21,250 minus that $48.50 for expenditures. The amount of profit is going to be $16,400.